Hey, I think we're live.
Awesome.
Hey, so what's going on, y'all? I don't know if anyone's watching this yet. I assume no, because I'm not a very popular human being. But should you watch it later, I'm Nick Eberts. I'm an outbound product manager at Google. Been working on GKE and Kubernetes for a while. My buddy Eddie is joining me, who is my brother from another mother. Eddie, why don't you introduce yourself to the good folks that are watching us?
Yeah, so Eddie Villalba, also at Google, application modernization engineer. They call me in when they want someone to figure out why this isn't working right. They want and how it actually works and cover all of North America actually. So
yeah, they also like to call Eddie when they're taking anti-patterns and cramming them into Kubernetes.
Yeah, right. Hey, I want to do this. And oh, don't do that.
Yeah. I'd like to run a Windows container.
Yeah.
All right. Jokes. So today, what are we going to do today? Today, we are going to talk about something I've been working on. In the past couple of weeks, I've been playing around with Argo CD. And the reason why I started playing around with it is because I noticed a lot of customers are using it, right? They're using Argo CD, they're using Flux, and they're using our tool config sync. And I just wanted to make sure that I had a handle on the experience for Argo CD. And if you're not familiar with Argo CD, it's a GitOps pull engine, right? It's a tool that basically runs in your cluster and watches a repo and looks for your configuration in that repo and then reflects that change across your fleet or across the clusters that you've got joined to Argo. So I know that we have a lot of really good features for fleets and GCP. And Eddie, what's your favorite fleet feature, man?
I mean, just the fact that we're kind of, recognizing that the fleet or a lot of your clusters, because we all know, right, at some point, one or two clusters isn't going to cut it for most large organizations. You end up with either lots of little clusters or lots of little medium-sized clusters, whatever it may be. But understanding what are all of those cross-cutting concerns that you as a platform operator have to deal with across all of those clusters, all the way down to the identity, right? So the way we do Fleet ID, the way we kind of, give you this one way to manage all of these environments, I think is cool. And the stuff that's coming down the pipe that I think is even cooler in the sense that fleet becomes a first-class citizen, right? And I think that's important, which, being part of the open source community and CNCF and Kubernetes for a long time, it's what we've been really probably wanting since the days of, 1.0, right? That was overkill.
Cluster iteration.
Yeah. God, how many iterations of that have we seen?
Right.
But I think this is a good compromise that, we can do at scale in the cloud with what we have. So.
Yeah. So my favorite part of fleets is we have this one capability. So Google Cloud's a little unique in that our load balancers, our public load balancers, can give you an Anycast IP and then have backends across all of the regions that we have, right? In Kubernetes, though, that can be challenging. So most of the time you interop with your load balancers in Kubernetes world using, you're either using an ingress controller with an ingress object, or you're using, maybe you're fancy and you're using the new gateway spec. But either way, those things are built to actuate and make changes to one load balancer, typically. From one cluster.
From one cluster.
When you have multiple clusters trying to make changes to one load balancer, you're going to get into race conditions. So what we did is built a controller, multi-cluster controller. We have one for the ingress spec and one for the gateway spec that allows you to have a, what do we call it? An admin, or there's like a controller cluster, one cluster that has this multi-cluster object.
Yeah, the cluster you select to be the one that's going to be the controller.
I got the technical term for it, but Gary will probably get on me for that. Anyway, So you post this object, and then the controller itself manipulates the load balancer, organizes it so that the clusters that you want become part of the back end, and you have this ability to have an Anycast IP that distributes traffic across multiple clusters, which is pretty nice. So that's probably one of my favorite fleet features. I've done some tweet demos on it.
But it's also the Google implementation of something that we came up with and also gave back up to the community, right? So I want to also focus, like we're still focusing a lot on the community. So multi-cluster service and the multi-cluster ingress are all things that we put into upstream, right? So it's not GA yet, but it's there. So the fact is, now other cloud providers can implement it the way they want to implement it. But this is just our implementation, just how we have our gateway API. And we're using the gateway API again that we brought up into the mainstream and upstream Kubernetes, but we implemented it first in our process, right? So same kind of concept.
Yeah, we've put in a lot of work there.
Yeah.
So I mean, we can wax poetic about these things, but I think today let's just get to the topic. So the topic is Argo CD, right? And GKE with the fleets components that we have. And so the challenge that I gave myself was like, can I build a fleet of fungible clusters with GKE and Argo CD using those fleet components? And what I mean by fungible clusters are like, I believe that if you have a fleet of clusters, you should be able to blue-green new clusters right into that fleet without having to do any manual intervention. So you should be able to drop a cluster into a fleet when that cluster has a certain label on it, or with Argo CD, it's a label in the secret, the Argo CD cluster secret. A bunch of stuff happens based on how you identify that cluster.
Yeah, taking the concept of cattle and pets for cloud native software and bumping it down to the platform, right? The platform itself should also support that kind of concept of cattle versus pets, right?
Yeah.
It should just be a bunch of cattle, right?
Yeah, so the things like, I don't know, this is just scattered, right? I'm just trying to organize my thoughts here, but there's layers to, I think, building a fleet, right? The bottom layer obviously is infrastructure. There's things that you could do to remove some of the infrastructure you have to manage, like if you're using GKE Autopilot, then you don't have to deal with nodes anymore, but you still have to create the VPC, make sure that your organization and GCP is set up. All this sort of peripheral stuff has to be done. Now, we've got some really good blueprints to get rolling on that. So you shouldn't have to start from scratch. But when I built this demo out, the infrastructure components that I built, I used a tool that I maintain, and I'll show you that later. But basically, I just, put out one project, one VPC, and then laid down one cluster on it. And that one cluster is what I'm calling the fleet controller. So that, like we said, we have these multi-cluster services from the fleet side that need like a management controller. Now that controller actually can be one of your app clusters if you want it to be, but I think it's cleaner just to have it aside for now, right? And I also had to have Argo CD running its own cluster as well, so I can put together Argo CD and these centralized KRM, these Kubernetes resources, and I put them all on one cluster, and that's what I'm calling the fleet controller. So you've got the fleet controller, and then you have application clusters, fleet application clusters.
So in practicality, would we build this out like that controller? Again, I'm trying to remember, like, do the fleets all have to be, do all the members of the fleet have to be in the same project today?
No, but all the members, when you create a fleet, it is associated with a GCP project.
Right.
And so when you register your clusters to the fleet, if they're in the same fleet, they can be in, each cluster can be in a different project, but then they'll be registered to the fleet project.
So you can put like this cluster that's going to be your kind of control cluster, kind of in like a shared VPC, kind of like central shared environment where this is more of like, your administrative kind of VPC project kind of example.
No, precisely. And so like the layer cake of configuration, right? So you've got your infrastructure as code. You've got your fleet controller and all the configurations and the installation of Argo CD. Then you have the configurations that all of your application servers are going to share, right? Like, for instance, in this demo that I built, I installed Anthos Service Mesh with a managed control plane, and I'm using the Anthos Service Mesh gateway, which is an Istio gateway. So that Istio gateway is in the sort of application clusters config. So every application cluster that gets bootstrapped gets the gateway. which makes it really nice then. So all I have to do is drop applications in any cluster, and the kind of the front end is already there, and the certificates are already kind of dealt with. And then on the top is this concept of a workspace or a team. We're kind of toying around with what we're going to call it, but the idea is that you're likely going to have some organizational unit in your company of human beings that all would kind of sit in the same RBAC boundary. Right. And in Kubernetes, that means that you'll probably have multiple namespaces where the same group of humans probably need the same level of access.
Right. And it's important to like recognize that this concept of fleets kind of requires that namespace sameness as like a guarantee, right? To kind of make things work correctly. So
yeah. Stay tuned for some stuff we're doing there. End of Q3, we'll have some fun stuff to talk about. I'm not going to talk about it on a stream, but the way that you achieve namespace sameness now is through using a GitOps tool, and we'll get into that in a little bit. But anyway, these are the layers as I see them. One quick thing, I'm going to pop over to this other picture. I just want to describe the difference and call out the difference here with Argo. So to compare it with config sync, and also Flux for that matter, these are other GitOps kind of tools, right? The way that the config sync and Flux work is you have clusters directly syncing with the repo, and they have this notion of cluster selectors so that you can tell a particular cluster which config it needs to sync from the repo based on either a label or like a hard coding the cluster name. Usually labels make more sense. So you could do things like wave one label and then push a set of config out only to the clusters that are in that wave one group, right? But the point here is that you're directly syncing the clusters with the repo. So this is a true GitOps pull method, right? With Argo CD, you can do that, but it gets verbose. And so the pattern with Argo CD is a little bit different. The pattern with Argo CD is that you have when you're talking about doing multiple clusters, you have a centralized Argo CD controller. And then that thing orchestrates, that thing watches the Git repo, watches for changes, and then orchestrates those changes across your fleet of clusters.
So I'm going to be the devil's advocate here, right?
Yeah.
I know we want to get to the build, but like if we talk about like, and I know like both you and I have had this not disagreement before, but debate before, like what is GitOps, right? Like, so if I go to like Weaveworks and I say, okay, they're the ones that kind of established the standard, right? They technically created the term, and you go and you say, what are those key characteristics? Like, what's different between Argo CD in this example or like a Jenkins or something like that? Whereas when you look at what Weaveworks says, part of GitOps is there's some kind of controller, which Argo is running in this case, that's looking for changes for state. But in this case, is Argo also looking, is it doing a watch on everything it deployed in cluster so that if a change happens, idempotently in the cluster, let's say an admin goes into a cluster and makes a change, Argo is going to go and say that is different than what is my master, my goal, my Git master, right?
Mm-hmm.
It's going to roll back those changes.
Yeah. So you still get drift prevention.
Perfect.
In this model, although this is not
debatable, right?
So
yeah.
If there's a network partition between your Argo cluster and your other clusters, then you will not get drift prevention because it doesn't have line of sight to check. It's not going to know that anything needs to revert. We do have this debate, and I have to throw it out there. So for me, GitOps is a thing that's been around for a while, which just wasn't called GitOps. And I like to distinguish between GitOps pull and push.
Yep.
And I think that there are a lot of tools that are GitOps pushing. Argo can do the pull again, but you'd have to, the patterns don't really fit well with it. But like Flux and config sync are more traditional pull methods, I think.
Yeah. Yeah. But it's just important to call it out. It's important to call it out, right? Because everyone thinks like, you mentioned GitOps and everyone immediately goes to that definition, because it's just what's there, right? And
Yeah,
people see.
I don't know. I may be an outlier, but back in the days before we had these pull tools, and we were just
I'd still commit code to Git, and there was some automated tool
and that change would
do
get
it
out via pipeline. That to me is still GitOps. I don't know.
Exactly.
It doesn't matter though. It's just a word.
Right.
It doesn't matter. The benefit of the drift prevention is a pretty good value, I'd say.
Yeah.
All right, so this is what we're gonna build. You can see here, I'm actually gonna have more regions, but basically you can drop clusters in and they bake from the fleet controller. You've got that single global load balancer that'll distribute traffic across to all the apps. And we'll do a test where we've got an app that tells you which kind of zone it lives in, and then I'll add one closer to me and you'll see it pop up, switching to the closest zone. And then the last thing that we're going to go through, if we have time, is a progressive rollout, but not just a progressive rollout to one cluster, but a progressive rollout to one cluster with a gate that then goes to the next cluster. Because I'm actually curious your thoughts on this. My personal opinion is that it's probably unlikely that you're going to roll out an app upgrade to your entire fleet all at once. You're probably going to use, if you're using a fleet, you'll use waves. And the first wave will probably be small, and then they scale out as you go along.
Yeah, I mean, I'd say, again, that's also very debatable. It depends on I call it the maturity of where you are in your operations.
Fair.
There's some customers that can handle that kind of wave process because there's a lot of networking, customer impact stuff that has to happen with wave that if you don't plan correctly, because let's be honest, half of what we see is distributed monoliths running in Kubernetes, not microservices. So it's not always built that way, but those customers and those people have more mature setups. Absolutely. That's the preferred way of doing so. But
yeah,
just realize there's a lot of other concerns in doing that, right? So
yeah, it's we I don't want to say we hand wave, like those challenges are so specific when you get into the data store, like or stateful applications, that solving for them becomes like a very intimate conversation with your customers or with your
or internally in your engineering team.
Yeah,
exactly. Something has to happen, right? Like, if you're not written in an event-driven way, it's going to be tough, right? It's going to be it's going to be an issue. But this is where you want to be, right? This is like the golden kind of path to offer services and be able to upgrade your services in this kind of wave process. So.
Yeah. All right, so I think we should dig in.
Cool.
So first off, so there's a tool that I use to bootstrap all the infrastructure and the first cluster. Actually, the first two clusters. It's a tool that Eddie and I maintain called the GKE POC toolkit. Once I figure out how to use these banners and things, I'll put a link down to bottom. I'll put it down at the bottom or something. But basically, I have, you pull the tool and and then you initialize the tool. And when you initialize the tool, you get some files. And where is it? Config.yaml. So in this demo that I'm going to walk through today, which I have out in another GitHub repo, this is the config that I use to pass into the GKE POC toolkit CLI. The only thing really important here to show is that I'm turning on multi-cluster gateway, Anthos service mesh. I'm not turning on config sync because we're using Argo. And then I actually have two clusters, but I commented it out. But the idea here is that this tool will allow you to take n number of clusters and it will deploy them into your VPC. And it uses a lot of really sane security defaults. Anyway, so this is the config that I used. And then all I did was want to create and pass in that config file. Takes about 12, 13 minutes. And I had my environment in two clusters. I'm not going to make us watch
paint dry.
Yeah, watch the standard out from that script, but it's there. And just to show you like what I have, we can drive through here. You can see, let me just zoom in a little bit. This is the Google Cloud Console. we've got these two clusters. I've got one labeled MCCP Central. It's the multi-cluster control plane. This is something I'm calling it. It's not like a really permanent term. And then I have one GKE standard cluster running in US West. And other than that, I mean, I could show you the VPC, but trust me, it's there. Otherwise, these things wouldn't exist.
Right.
And there's not much else that's deployed. So the first thing we need to do, though, is install Argo CD onto the managed control plane, right? I wrote a script for this. Where is it? It is right. It's called Fleet Prep. But one quick step before that is I need to clone the repo where I have all of the kind of the base configs that I'm going to push, and then move those files into a new location. So I'm just
this is the repo that Argo is going to be kind of looking at. Is that what you're saying?
But it's not yet completely hydrated.
Gotcha. Okay.
So, and I just want to delete that just for completeness. But yeah, so I just pulled in these two repos, or I pulled in one repo with these two folders. This is a customized package that I wrote so that you can install customize. Well, the customized package already exists. Argo maintains it, but I added a layer on top to configure Argo CD with an ingress, a GCLB ingress, so I can have a managed certificate and expose it publicly.
Gotcha.
You probably won't expose your Argo CD in production publicly, but for demo's sake, it just makes life a little bit easier. So this is out there too. If you're just messing with Argo CD and you want to install it real quick, there's a customized package that I have embedded in this repo you can use. And then the other thing that's in here, this is all of the config, right? And we'll go through this as we go through the demo.
So in the parlance of GitOps, this is like for a DevOps team, you have your app repo, and then you have your config repo, right? And this is like the config repo that
yeah. And to make my demo easier, the apps and the cluster config are actually going to be in the same repo that I'm syncing with, but different paths, different folders. Gotcha. And the apps themselves will be in different branches. Gotcha. But yeah, like you can see right here, here's the multi-cluster stuff. This is what the ingress looks like. And the only thing that you need to change in this folder to make it work, like the services are all fine, is you need to add in
the gateway IP.
Gateway IP. And so I have a script that kind of does all this stuff that I'm about to run. Let me just make sure we're all set here. It's the Fleet Prep script. I made this really big, so I have to scroll a lot. You can see it does a bunch of things. It's going to create a, well, actually, let me kick it off and then we can talk about what it's doing.
Yeah.
Let's see.
I have to help you pretty up your shell script.
Oh, whatever, man.
There's a new tool. I got a shout out to the folks that made Gum. I don't know if you heard it. Charm.
No.
It's like, basically it's written in Go, but it's a pretty cool like add-in to shell scripting that gives you like a really easy way to do things like drop down menus, so people can choose things, and it pops it in. It's really cool. So it makes it more of like a user driven CLI almost for shell scripts. It's kind of cool.
Oh yeah, I'll have to check that out. I mean, if I had more time, you know me, I just would have written this in Go, but I basically was just kind of thinking about what the API might look like. And it just was quicker.
I think shell script. I think for this purpose, this is perfect for a shell script, though. But I don't think there's anything necessary. It's a little more complicated. But
let's see. I'm gonna turn away this for a second so you guys can't see me put in my pat. There we go.
Come on.
You do need a pat token, and you do to run this. I'm using GitOps CLI because it just makes things a lot simpler. All right, so that's done. All I did was set the repo and set the So it's the GitHub CLI is going to create a repo, and then I set the PAT token, and I gave it the project ID that I'm using. So let's go back now to complete prep. God bless recursive searching.
Mm-hmm.
Hang on.
Careful, the PAT might get shown again.
There you go. Okay. Now it's going to run through the script. I didn't clean up the one IP. That's okay. It's gonna go through. So it's just doing some basic stuff. I'm creating cloud endpoints. If you've never used cloud endpoints, basically I use it just to get a DNS name for a public IP. So I create this object, and then I post it to the gcloud endpoint service, and then I'll get this host name mapped to the public IP that I just created, and I created a managed certificate for Argo, and then an ingress. So an ingress in Google Cloudland, that's going to create an XLB, or not an XLB, but a Google Cloud Load Balancer, an external Google Cloud Load Balancer. And it's going to use the IP I made, the front end config that I have set up to do redirect from HTTP to HTTPS, and the managed certificate. And basically, this is going to take all traffic and send it to the Argo CD server that's going to be deployed when I use that customized package. Make sense?
Yep.
What else? And this is kubectl apply-k. Whenever you see that, you're applying a customized package. And
by the way, for like a customer who wants to deploy this, it doesn't have to. You can annotate that with an internal regional. It can still be a secure endpoint.
Oh yeah.
So
yeah, there's an annotation, and then it'll change the behavior from an external IP to an internal IP. And then if you want to make it static, which I recommend, you would just, you'd actually just put the literal static IP that you want to use in the annotation. Correct.
From the VPC of your region you want, from the subnet of the region you want.
Right? Yep. So I'm also getting ahead of the need here to create some other IPs that I need for the demo apps later. I'm just doing it now because it takes a while for managed.
Yeah, they take a while to sync up
and then I'm just validating that my managed cert exists. So I've cheated a little bit here. It should already be registered, so we shouldn't have to wait for the certificate to register itself. So it should go by pretty quickly. And then I'm grabbing the Argo CD, the Argo initial secret, logging in, adding the MCCP cluster. You don't have to do this, but if you want to use labels in the Argo CD secrets to dictate certain config to apply to that certain cluster, you have to join it and give it a name. So I'm adding this even though it's local, just to get the name then. And you can see here I'm passing in a label where environment equals multi-cluster controller.
And this is this is just an Argo CD concept for
right.
Software.
Yeah.
Right.
I can show you what the secrets look like so you can get an idea. But basically, Argo CD, when you do this cluster add, it creates a secret. In that secret, it puts a kube config of the downstream cluster it's managing, like a token, along with any sort of label that you want to add to it. And then you could use those labels when you're defining the way that you want to send certain configs, certain clusters. And we'll look at that later.
Gotcha.
And then I just created the repo. I swapped out a bunch of variables that I needed to swap out, committed it to the repo I just created, and then added that repo to Argo so that I can use it.
Gotcha.
I have this stuff in here. What's really interesting, so my buddy Matt Williams, who's also a CE at Google, he figured out how to use this tool that we have called Connect Gateway. Oh, yeah. So the Connect Gateway allows you to use a gcloud command to get a credential to a kube config credential to do stuff, right? So rather than give Argo CD like God mode in a kube config in a secret, what you could do is you can you can rotate the secret to use the gateway instead.
Okay.
And then that way, all you have to do is give the workload identity that Argo CD is running with the role-based access controls it needs to manage those other clusters. And then you get out of the business of having to create the role and the role binding in every cluster you're managing and creating that secret.
Well, I mean, Connect Gateway is even more than that, right? It's like I don't have to worry about OIDC.
Right.
I'm using Google identities. And then also the benefit is it's through a proxy that's hosted in the cloud. So this Connect Gateway can work for even private clusters that have no external network connection to the API server. It can work to clusters on premises. So it's actually pretty powerful.
And yeah. And so I didn't show you beforehand, but this wasn't here because Argo wasn't installed.
Right.
One thing that I realized is that I changed this script to install all of the application sets. So not only are we getting the central stuff, we're actually going to get all of the other things starting to push out. Which is cool. I mean, it's fun. So this is I should probably dissect this a little bit because
can you
unique to Argo.
Can you configure the initial setup of Argo? I thought you can configure the initial setup of Argo CD to like a config map where it doesn't do like an auto deploy. It just says, well, it doesn't do an auto sync. Like it registers the app, but it just says I'm not synced yet. And then that can be a manual.
Yeah, that's the definition of the application. So let's actually talk about that for a second.
Yeah, that's important, right?
Okay, so the way that you do multi-clusters stuff with Argo, and I'm a novice still. I've only been doing this for a little bit, but I've had some great help from the Argo community in the CNCF Slack.
Great.
Shout out to them for helping me out here. But so the way that it works is you have the fundamental unit of work, I guess, if you want to call it, in Argo is an application. Inside the application, let me just look at one. I don't think I have any applications here. Actually, I can just look at it in the portal. So inside the application, each one of these tiles is an application. So if you look at this application, it'll give you a slimmed down version of the manifest. It's actually bigger than this when you create it, but this application is a definition of basically which repo the application should sync with, the path in that repo, the revision, the destination server. So in this case, it's the control plane. So the server is local. Mm-hmm. And then you can set your sync policies. If you want it to prune, self-heal, if you want to allow empty, and then you can set your retry too. So if you have things that a lot of the times in Kubernetes, there is some chicken and egg. So you need to just set a little retry so you don't have to manually stop and restart the sync.
Or trigger a rollback or stop the plan.
Yeah, exactly. But so the application, the point though, is the application represents the cluster and the repo and path that it's syncing from, right?
Gotcha.
So if you have 5 clusters, you have 5 applications. You can't have one application syncing 5 clusters.
5 clusters.
So the way that they solve for that though is by creating application sets. Mm-hmm. And application sets are just they're template generators, right? So templates and generators. So basically, you have an application set. You provide it some generators, and they have a bunch of different generators, and we'll look at them in a second. And then you give it a template, and then what it does is it iterates over the generators and creates n number of applications based on the output of the generator using the template, right?
Gotcha.
And one neat thing you could do with these application sets is you can use what's called a Git generator, and you basically point them at a folder, right? And that Git generator looks at the folder and says, okay, every subfolder in this folder is going to be an application.
Uh-huh.
So now I don't have to create an application set for each subfolder. I create one application set. It's watching this folder, and then it does work based on a folder. So then if I have an application set watching a folder, all I have to do is drop a new set of YAML in a new folder, and it's going to create an application automatically.
Gotcha.
And so the other thing that it's watching, so I'm using 2 generators. I'm using the Git generator, and then I'm using the cluster generator. The cluster generator looks for a label selector, right? So it looks at all of the secrets, all of the Argo secrets that you have for each cluster, and it looks at the metadata, the labels in the metadata, and it looks for a match. And if that cluster matches, then it will create an application. So if I have a folder with 2 subfolders and I'm using a label selector that selects 3 clusters, I'm going to have 6 applications.
Right. 3 applications, each 2 clusters. Right.
Yeah. And now I can show you what those look like because I keep them here, even though, and I'm manually applying these. Argo, you can do like, it's like app of apps kind of thing. I could have them automatically deployed. I could create an app that watches this folder.
An app of an app.
But it's fine. So I actually manually kubectl apply these right now. But if you look at the central, no, the central is a bad example, multi-cluster controller, you can see it's got 2 generators. The matrix generator is the generator that allows you to use more than 1 generator. So generator 1 is Git. It's looking in this repo that I just created, and this path.
Right.
And then it's using this cluster generator to look for a multi-cluster controller, which is just 1 cluster.
Gotcha.
And then the template, like this name comes from the name of the secret, right? Path.base name is literally this.
That,
right? And then the destination server comes from the secret as well. So I don't have to do, all I have to do is drop code in there and it gets deployed.
It just gets dropped in.
Yeah. And the same thing with the application clusters for tooling, right? So I have one for common tools like the gateway.
Yep.
So it's just going to look in the repo in that path. I'll look for anything that's labeled as prod and then basically do the same thing.
Nice.
So if we look in the sync repo under app cluster configs, you can see I have 4 folders.
Right. And
that's each one of those folders will be an application times the number of clusters that are labeled as prod.
That's right. Gotcha.
So that's why right now, once I created the repo and set up those application sets, I have the one control plane with the control plane stuff.
Right.
And then I have all of the application tooling installed in the only cluster I have.
Right.
So it's pretty cool, man. And this UI is, I give them props for the UI. I love it.
Their Argo CD's UI has been the dopest UI for this kind of work for just the beginning. So they've done a great job. So I'll give them that much.
Yeah. And so I'm going to add a cluster because it's going to take some time, but I want to talk a little bit more about some of the things I had to do to make this work with ASM.
Yeah. Okay. Oh yeah.
Because there's some tricks. So I have another bash script that's ugly.
I will clean up for Nick.
Yes, please do. And it's just cluster add. Now,
what you're going to be doing is you're going to be adding that US.
Actually, I just realized something. Right? I wonder if I had some legacy. I just want to see. You can always look in here. Yeah. Okay. So that cluster is already installed. Yeah. So I have to uncomment some things because I was messing with this before, but let me do this. Let me make sure everything's sane. Okay. And then this is what the secret would look like if I was using Connect Gateway.
Gotcha.
I haven't quite hashed it out yet, but I've got it in here. Matt and I are working on fixing that. Okay, so I'm going to run this script, and
this script just takes the existing cluster, adds it to the fleet on the Google side.
Yeah, it's like if you look. Well, let me start running because
go ahead and run it. We can talk about it while it's running. Yeah.
So scripts. Is it?
I think it was
feet
add.
Wrong with me. Cluster add. That's right. And then I'm going to change the name because we're going to pop it in. Actually, let's put it in. We'll put it in East. I'm going to give it a location. And then I need to change that's the control plane IP. I'm going to use a standard cluster, and I'm going to put this one in wave 2. Right, so my other cluster was in wave 1. So when we get to the application rollouts, you'll see why that's important.
And all you're doing there for that, this is not a GCP concept. This is a tagging concept that you create, a construct that you create.
So let me just make sure that lights. If it's going to break, it's going to break right there. Okay, we're good. So at the very end here, you see me. I have to label the region differently. If it's autopilot, I actually do a regional. You can't do a zonal cluster.
Yep.
So that's why I have the if statement here. But standard cluster. Actually, that's backwards, I think. Anyway, it'll work. These labels are what's important.
Yep.
So when I give it this wave,
yeah.
Here, I can show you, actually. Let's look at something and make sure I'm in the right context. Yeah, kubectl, secrets. Already, my context is already in the Argo namespace. So this secret right here, that's the local cluster secret that I created.
Right.
I do just because it's faster. You're going to see that's all. Every label that I'm passing into that command is just a label here.
Yep.
That I can use later on in those templates.
In the templates, right?
Yep.
Gotcha.
Okay. So that's running.
So for all intents and purposes, to Argo, the secret is kind of like the cluster identity.
Yes.
Right. It's using the KSA for it's using that secret almost like an account kind of scenario.
Yeah, it's what the Argo server component is looking at.
Cool.
And it's what it creates when you create an Argo cluster that's downstream. So while this is going on, and I am going to add the where am I at. So I also have this team app script, right? And it does a bunch of stuff, but I basically, let me just make sure it's in here. Yeah, I have an app template in here. So it takes that app template, hydrates it, puts it in a team folder, gives it like RBAC and quota and all these things, and drops it in an Argo rollout.
Mm-hmm.
I want to get that going though, so you could see the where am I application now bootstrapped in, getting responding from West Coast, and then when the East Coast cluster bakes in, it should swap over to East.
Sure.
So let's get that added. So we are looking for team app add. Where am I? P is project. T is the team name that I'm going to give it. H is the host name, and then I'm also giving it a wave.
Right. Now you're basically mapping up the wave of the app to the waves that you assign to your clusters. Is that right?
Yeah. Well, the each wave watches a branch, and so when I did that, I just created a branch for that app.
Well, what I mean is so I'm a platform operator. I have so again, we're talking about the whole purpose of this conversation. The problem statement was I'm creating fungible clusters, right? So I want a wave. I want my clusters have a wave designation. That means that when I do an upgrade of a cluster, let's say GKE, one version of GKE to another version of GKE, I have a wave pattern. But my applications may have a different wave pattern because the owner of the application would define, I want to roll this out in 5 waves instead of 1 wave or whatever, right? Do they have to line up, or are they independent? Right? One is for platform operations and one is for
no, I didn't think about it that way. I basically gave wave labels to each cluster.
Okay.
And I have, for demonstration purposes, I have 2 waves.
So you lined them up. You basically lined up the waves.
Yeah, but the way I see it is I can add another cluster into that wave and then deprecate the old one.
Sure.
And work should just start. right? And the new cluster in the same wave. And then I can use the wave label as a way to, you'll see, to generate applications that point at specific branches. So that's what I've done. And I'll show you right here. When I ran that script, I created 2 application sets. Now there's a fancy way to do this and do it from one, but I think just because it's just easier to explain this way. So basically the only difference between these 2 application sets that I just created is the target revision is looking at.
Sure.
So when I promote a new image to wave 1 to the wave 1 branch, it's going to kick off a rollout.
Right.
And then once I'm happy with that, and it's going to be a progressive rollout. When I'm happy with that, I can promote it to the wave 2 branch. And it'll roll out to the wave 2 servers. Because you could see that the revision matches the label.
I got you. So for me to do a rollout, let's say of an application in waves, there's got to be, and this is what we were talking about, the manual gate is really Git and basically a promotion of saying like, hey, I got a PR from this branch to another branch, this new change, right, of the image name or whatever, right? So, okay.
That's still cluster install still running. Something funky happened in my terminal, but
that happens in VS.
Yeah. So where my app should be rolling out to this cluster, sometimes it takes a second to trigger. I actually set up. No, you know what? I didn't set it up with this one. So what you can do to make this faster, because the watch is on a poll. I think it's on 30-second poll. What you could do is you could just create a what's it called in GitHub?
A webhook?
Yeah.
Okay.
It's that push, like every time a change happens through your repo, it lets Argo know that there's a change, and then it'll do the same.
Yeah, webhooks. Yeah.
Webhooks, sorry. Yeah. So if I had done that, this would be faster, but we're stuck in between a 30-second poll.
Now, I noticed on one of your commands, you're adding. Why is there a gRPC web flag? I haven't seen that when I've installed Argo CD. What is that?
Because I'm doing it through the GCLB load balancer.
Okay.
And when you do that, you're basically saying it's not gRPC. You're doing it over HTTP.
Oh, because I thought I said gRPC web Y. So it was yes.
Right.
So that it's the negation of that?
Yes. Okay. As I understand it. Because otherwise you get a bunch of error. It would work, but you get a bunch of error gRPC errors.
Oh, right. Okay, right. That's what I'm saying. So that is gRPC web. It's putting.
Oh, okay.
It's
maybe
putting,
I don't know what gRPC web is.
Well, gRPC, like you said, is gRPC. If you just did it by itself, it would try to talk directly gRPC, and it would not potentially work if it's because the node app. So like if it's a web proxy, right, for a web front end, it needs to be able to have, hey, I'm going to talk gRPC from that web app to the back end in gRPC. And because of that load balancer, we have to say, yeah, use gRPC web on the web component, right? Which I'm guessing is written in Node. I haven't played with it yet, but okay. I that's what I was just verifying, like why it's doing that. So okay, that's cool.
Here, let me look. I'm a little concerned that I don't see the thing. So I'm just gonna get application sets and take a look and see what's going on.
So are you on the right context? You're
oh, you know what? It changed context when that was being installed.
Yeah.
I don't want to mess with it. Okay, well, East is done, so I didn't get ahead of this, but yeah, let me here. That's installed, but maybe there's an issue. Oh, you know what? I just installed them. I didn't roll them out. I forgot. Sorry. One script scaffolds everything out, and then I have this rollout script, which needs to be run in order to set up the branches. So right now they're it's looking.
It just knows about the configuration. But
yeah. So I need to run this rollout script. Let me run that real quick. This is live, y'all. Told you it was going to be a shit show. Let's see.
It's fun.
Yeah, I agree.
How do we break things? I love it.
All right, so that's not the right one. There we go. Okay, and then I'm going to change the wave. So this is where I'm deciding which wave it's going to go to. So I'm going to set it up to wave 1. What is up? Let's just take a look manually. Check out wave 1. Let me just make sure it's up with name. It should be because it's brand new.
Just do git branch -v. Just get the branches. Get branches.
No, it's good.
Oh, okay.
Let me just do git add, git commit, and a push. There might be some kind of like this is the first time I'm running it thing. I thought I sorted this stuff out already. Oh, there's no change. So yeah, it should be rolling. Should be popping out. I'm not quite sure. So East is adding. You can see the East.
Yeah.
In.
See the East is adding.
I don't see the Where Am I app. So why is the Where Am I app not dropping in?
But that's in the Where Am I app is not in main though, right? It's in its own branch.
No, it's in both.
Oh, okay. Yeah, but what I'm saying is that Argo is only looking at the wave 1 branch. Is that right?
Right. It still should create the application and it should fail because the branch doesn't exist if that's the case.
Gotcha. Yeah, because I don't think there's a branch.
Oh, I know why.
Yeah.
That's why. That's why the whole thing didn't work. Okay. I actually don't need to do anything else.
Yep.
Yeah. Got to fix this script for the first time you run through it. Okay. I may as well just do the next one too.
Yeah, wave 2. -b.
2. Let me fix that. Okay. Let's see. It still should have already started to roll those out. Yeah. Oh, out of sync. That's why I had sync chosen. Huh.
There's Where Am
So
I.
beautiful. This was there the whole time and it would have helped my troubleshooting a lot. There it is. And it was trying to sync. It was out of sync because it was trying to sync with a branch.
An empty repository, or no, empty branch, right?
Now you can see the rollouts occurring, the pods coming up. We still might be able to catch it before it gets over to East. Oh no, it's not rolled to East yet because I haven't.
You said you didn't.
I didn't promote it to wave 2, so we'll be good. Okay. So once this pod gets healthy, then I should be able to refresh this and see the Where Am I metadata about the location of the pod that it's responding. It's adding a node, so it's going to take a bit longer. That's okay. Oh, one thing I did want to go back while all this is baking. One really interesting thing that I want to talk through so that people know that they can who are coming up against this can solve for it. It's specifically around ASM. So the way that ASM MCP managed control plane works is, you basically have a control plane revision. It's probably easier to show from here. And I think, so it's in app cluster config, Istio system, ASM. So the managed control plane is set up already. It exists outside of your cluster, right? So it's a centralized control plane. It doesn't know to install the things that it needs in your cluster until you install this control plane, right? Revision. So when you put this revision in a GitOps system, what happens is the control plane revision object gets installed, which is great. But and then the ASM gateway will immediately go to install. And the ASM gateway is going to fail perpetually because it's not going to be injected with the right Envoy image. Correct. So the way MCP works is control plane revision is posted, MCP watches for it, sees that it's posted, and then installs a mutating webhook. So there's the time between the control plane revision being installed and the existence of the mutating webhook. And if your gateway or any of your sidecars kick off before the mutating webhook gets installed, it's going to get stuck in an image pull back off.
That's right.
Forever. So what I did was I created a webhook. And this is one thing that Argo has. I think we have it on the roadmap for config sync. It's pretty sweet.
It's like a web. It's like basically like a wait, right? Like a wait.
Yeah. I mean, I have it. I wrote this little image that uses kubectl to check for the webhook's existence.
Right.
But what's important here is that I'm using this hook annotation. So when you say sync, that means it's going to happen after sync, or no, during sync. Everything is syncing in the wave. So in Argo CD, you have waves, and you can go negative integers or whatever, right? So you create waves in which things sync. And then you have a hook that can either run before, so a pre-hook, during the sync, so at the same time as everything else, and then a post-hook. Right. And so I have this set, like the next step isn't going to pass until this hook succeeds. It's running with all of the wave one stuff. And then I've got the actual deployment on a post sync.
Yep.
And so when you see in here,
that's how you're doing the chaining kind of thing. I've had to do that a bunch of times in Helm for the same reason, right? Whenever there's a mutating webhook waiting for it, Helm has those hooks as well. So, okay, cool.
Yeah. So before this deployment kicks off, that job's going to run. The job's going to wait till the mutating webhook exists. The job finishes. Once the job finishes, then the deployment rolls and everybody's happy.
That's right.
Let's see here. It's synced. Now I bet we're in a cert issue.
Yeah, I think we're just waiting for the cert to. Oh, you said the cert was no, because this is a new cluster, right?
Yeah, but the certificates I generated ahead of time. I tried to get cute. But if there's a timeout, and if you don't generate if the cert can't register itself a certain amount of time, it just fails.
Network services.
So load balancing. Let's see if we've got some failures. Oh, they're active. They should be good. I wonder if they're actually using them though.
Check the load balance. Yeah, so I check the.
That's this one. Yeah. Where am I cert? Rollout demo cert. And then if I go back to Oh, let me see something else. So another thing that's interesting with ASM that sometimes can happen if your gateway is in rotation behind the load balancer, but there's no virtual service behind it, traffic will black hole because it's got a healthy gateway, but that gateway has no. So what you have to make sure you do is, this is an indication that maybe my ASM doesn't, the cross mesh service discovery isn't working.
Right.
Always in a live demo. All right, so.
Well, we can check it by going to.
Yeah, let me just see if the destination rules are in and the virtual services. So there could have been. Where do I put those? I put
that into the app, right?
ASM gateway. No, because I was. Here's a WebMy virtual service. There
you go.
Yeah, it's the wrong
it's wrong URL.
Something. We're testing my scripting live right now, y'all. So my apologies. So if I go in here and change it to Argo Spike, let me make sure. That should be only one, but then while I'm at it, let me just go in the template and make sure. I don't know why that didn't find and replace correctly.
Is it in one of your scripts?
Yeah, it's got to be in the script.
Hard-coded or something?
It would be in Team AppAd. Where's it roll out? No. Oh, you know what? I think I just didn't change the host name when I created it. This is just my fault. I did a recursive lookup and then I didn't change the host name to put it.
Oh, you ran the command, right?
Yeah,
right.
So my stuff works great. It's just my brain that doesn't work. Awesome.
Yeah.
All right, so host name of where am I?
Beauty of Argo is now that you'll make the change, it'll update.
Yeah, buddy. And then I'm gonna I almost never do this when I'm really doing stuff. I just use git, but because I don't know what that command actually does. It's a
see what it does. You can go to the terminal.
I know.
And show you like the 18 commands that it runs.
That should then reflect into all of the gateways. So let's look in here. I'm going to make this sync happen a little bit faster. Let's see if it catches. Okay. Let's see if that virtual service gets updated.
What?
Oh, it's rerunning the job. That's fine.
Yeah. But that virtual service just came in, didn't it? Yeah.
Let's see. No, it's still the old one. Let's see the desired manifest. Is this watching? Actually, this is supposed to be. Yeah, no. So this isn't watching a branch. It should be updated. Let me.
It also says syncing. So.
Yeah, but it didn't sync with the latest. I can tell you for sure because otherwise this would show up with
the spike
the right thing. So let's try it one more time.
You can't see the revision that app set is on. Compare it to your Git.
Yeah, I just have to go into Git.
Oh, there you go. Okay.
There it goes. No, it's running the. All right, let's see what the revision is.
Oh, did you just make the commit to wave 2 or wave 1? You're in the wave 2 branch.
Oh, that's a good call, man. Okay, that's why. That makes sense. So this is easy to fix. Git checkout main. Git merge wave 2, right?
Mm-hmm.
Then add commit. Oops. Nothing to commit though. How is that possible? No, it's good.
Yeah. Charlie Alpha.
So what do you I feel like we should be talking about something interesting right now while I fumble. You should be covering me, man.
I'm making sure. But no, it's still on the.
You know, Eddie's full-time job in our career repair development is watching over my shoulder for all the typos that I make. It's ridiculous. Okay.
It's up on the 3. So, you know what?
I can go see what the revision name is.
I saw it was 3CA something.
Yeah, there it goes. Now it's out of sync. Now the virtual service is updating.
Yeah.
Let me go make sure this is going to kick off quickly.
What's the polling interval set to by default on Argo? Remember?
30 seconds.
30 seconds.
Yeah, that's why you need that webhook from Git.
Yeah, I think the webhook. Yeah, I was playing around with that at one point. The webhook to kind of trigger it like a little bit faster. So.
Yeah, so basically, you don't even need to authenticate it. You just allow the webhook to throw. It throws a message at Argo, and then Argo's like, "Oh, there's a change," and then it uses its poll that can authenticate to actually get the data,
get the changes. Yeah.
Okay.
Yeah, we did that. We did that with I was integrating some GitHub Action stuff. Like CI was done in GitHub Actions, but they were using Argo CD for the rollout. So we were able to send the kind of the webhook from Git directly from.
Well, this is odd. The desired is the old one, and
private. What does it say?
Yeah, it went back. So I must have fat fingered something.
It's probably in your diff. Just go back to your Git and just look at the file in your Git on main that you're in. Make sure.
So I've noticed with Argo sometimes it has to play through all of the changes, it seems. So now it's going again. Now it'll be good.
That's the new head. That's 3CA.
Yeah.
Whatever.
Yeah. So now it's going to Argo Spike, which is the project.
Right.
And it should be, yep. Okay. All right. So if we're cooking with gas, yay.
Oh, nice.
And it is going to east.
Yes.
Because wave 2 is pushed out. I just did that. I just realized I just did that. So if I can back out wave 2.
That was just because we committed by mistake to the wave.
Yeah.
Branch. Yeah. But that's okay. That's fine. I mean, the point is that we have that control, but that control is all in Git, which it can be a good thing or a bad thing, right? But
right.
And that's just us because we're demoing technically, this would be like a protected branch, right? Like your wave 1 and wave 2 would be protected branches. So only PRs into those would be accepted, right? Can't commit directly to one of your wave branches.
Yeah, you would never do what I'm doing right now. I just really quickly, all I did there was get wave 1 back in sync with the other 2 waves. So we should be good. So if I delete the application set for wave 2, it would remove it from rotation. Another thing I could do is, do you know of a good way for me to in browser spoof like I'm from the West Coast? I've tried to do it with Chrome by changing the Latin long, and it doesn't really work.
No, it doesn't work. I know there used to be like a Chrome plugin that you could do that. It was like Tor, basically like a Tor kind of plugin, but if you're on our machine, that's not going to happen. That won't.
What else can I do? Oh, you know what? I think I'll do it with a VM.
Yeah, there you go.
So I think I even deployed one.
Well, since I'm central, I wonder which one I would hit. Would I hit east or west?
I don't know. You want the endpoint?
Yeah, give me the endpoint. Put it, I guess, in the whichever.
One else can go ham too. While you're doing that though, I'm just gonna make sure I can SSH into this VM that I created before. So I'm going into my, where is it? Compute Engine. Created a handy dandy West VM. I won't be able to SSH into it. I need to create a firewall rule, but I'm just getting the network tag.
Yeah.
Allow SSH. Brilliant. Good job, Nick. And then we'll go into firewalls. And then on my other screen, I'm getting my local IP. Okay. And we will create a firewall rule. Allow SSH from house. Actually, I'm probably just going to allow all from house. No, I'll be a good citizen.
No, I don't want to say. Don't do that.
Target tags. This is where I will put in allow.
I hit east as well.
You hit east? Okay. I don't need to. Oh, and then the source IP range is going to be my IP. I'm paranoid, y'all. You're not going to see me. Boop. So I'm putting in my IP /32. And then I'm allowing for TCP port 22, hit create, and go on. Okay. Let me put you back. There we go. All right, so that's creating. Now I should be able to SSH into this VM. Let's go back to it. I'm gonna get the gcloud command, and then I'll run it from my VS Code. That doesn't, something's amiss there. Okay.
There you go.
And then I should be able to curl this. So that means that the west.
Yeah, but you should have still gone to the east.
No. If the cross yeah. Something's amiss here. Let's see. So we need to look at the west gateway. Let me just make sure the virtual service is updated here. Argo spike. That's correct. Is it live? Yes. Let me see if the destination rules. I need to apply the destination rules. If I apply the destination rules, then this stuff will take care of itself.
Because I think the only change that you made was, and we accidentally hit West 2, was to the virtual service, not the destination rule.
And it is up. Just thinking through.
Try your VM again. Try your VM one more time.
Yeah.
And what error are you getting?
You
get internal. Yeah.
This is the error that you get when there's no. If I actually did a verbose, it would show me an envoy error. I'm pretty sure. There's a couple other things we need to do though. I think I'm going to sort this out just by doing these other things. So we'll come back to that in a sec. Let's see. So I have these region cluster configs. Another thing to be aware of when you're dealing with multi-cluster mesh is that, and this isn't the behavior we're seeing, but the default behavior for Istio is if you don't have a destination rule and you have services that have the same name that are joined to the same mesh, it's gonna round robin across all of the endpoints, including the ones in the other clusters. So I'll hit the ASM gateway in the west or east, and it should try like. It won't try. It'll literally round robin me to the downstream service between all the regions that.
Yeah. So from west, you can hit east central pod back in the back end, so you'd never know.
Right? So the way that you fix that is to create destination rules. You create destination rules. And I have one here for where am I stable service, and then I pick a failover.
Well, it's not just a destination rule. Because people have destination rules in Istio, but it's the locality setting.
Sure. It's the locality setting within the destination rule.
That's what's important, right?
So I have, I only have east and west clusters right now. East should be failing. Oh, it's failing over to central. West, I don't have a central cluster. This is what's happening.
Yeah.
Because I normally do this with 3 clusters. So to fix the problem that we have right now, all I need to do is take the west.
Fail to east. West fails to east. East fails to west.
Yeah, and do this. The other region doesn't matter because we're not using it.
Right.
And then we'll take the east. Fail it to west. Then I'm going to go ahead and do this for the rollout app now before I forget. Okay. So when I push this change,
make sure you're on the right branch. What branch are you on? You're on main?
I think so. Yeah.
Yeah. All right.
Yeah. Y'all look at my Git history on private repos. There's a lot of oops. or say commit one more time. All right, so let's see if that change pops in. This is fun. You guys are seeing how I kind of see and develop when I'm using Argo. The UI is key, honestly. Like
it's pretty slick. It helps out quickly troubleshooting
and when you're troubleshooting this kind of stuff. Mm-hmm. So I pushed that change. Those changes should be going to. I actually don't see any of the cluster specific stuff even being deployed though. So I don't think that those
go to the out of sync view. You filtered out of sync stuff.
Oh, here's the destination rules. Okay. It's altogether missing.
Your filters are your worst friend there. If you're not careful.
This destination rule is going to fail because it doesn't yet have the service the virtual service that it's pointing out. That's okay.
Right.
Because I haven't ruled that one out yet. So let me just make sure the destination rule is updated. West Central. No, it's not yet updated. Actually, so
we're still saying out of sync. It's still on the old.
Yeah.
It's still on the old head of master right now.
So not awesome, but what you can do is you can go into sync, you can terminate, because it's going to keep on retrying to deploy the virtual service that doesn't exist. And now I can resync just this one. No, it already kicked off. Okay, and it's redeployed.
Yeah, that's the new head. Yeah, that's the new head.
So I'm going to do the same thing here. Let me just make sure I'm working East Central. Yeah. Okay. So we'll terminate the sync, and then it should immediately retry again. Yeah, and it should pick up the change. Come on.
That's the new.
Yep.
Yep.
And yeah, okay. Mm-hmm. So those are in. Now I need to go back into my VM. Right.
Just make sure we didn't break anything else.
Yeah. Take a second for the rule to take into effect. No, it's still failing. The only other issue that it could be
is networking on your VM. Just firewall out. No. Do a verbose on the curl. See what is it? Is it actually Envoy? Is it ours?
No, it's getting past the GCLD, so it's got line of sight.
Yeah.
And then it'll probably throw an Envoy error. Let's see. Yeah, this is the.
No, that's the LB error. I don't think that's the Envoy.
So one way to check this, folks watching, is you can go into the load balancer, right? And make sure you've got a backend service for the region that's failing.
Because right now it says only one backend service.
East and west. No, we're good.
Okay.
Got east and west. So the gateway is healthy. Let me just dot I's and whatnot. So the West Gateway has a virtual service. That virtual service is correct. And the pods are up. Oh,
there's no pods in the, no.
Yeah. Wait, no, it's an Envoy. It's an Envoy.
Yeah.
And it's reporting healthy. So it is up. See, this is the image that gets injected. Yeah. So that's good. The service is good. The ingress is good. Why would it not?
Go to the West. Where am I?
Okay. Oh, maybe that's not injected with the sidecar. Yeah. Where are you? Another cool thing too that you could do. I'm just going to show this off. Team 2, and then I could see just the stuff that I've assigned to a Team 2 project. It's pretty neat. So the West Coast. Where am I?
Well, that's based on label.
No, it's there.
Oh, okay, I got you.
All good. What is?
So it's got to be an Istio route then.
I mean, I guess. It looked pretty straightforward, man.
Virtual service.
That's it.
Yeah.
Oh, I know what it is.
The screen is too small for me to.
No, I think I know what it is. So I might have gummed something up when I was installing the cluster, because I didn't use the script to add that first cluster. It was installed by the toolkit. So one thing that has to happen, you have to create an SSH cert. So I'm just going to run
for what? For the
back end, for the gateway. So the way that the way that TLS is set up is that I have an official managed certificate on the front end of the Google Cloud Load Balancer, but then it gets re-encrypted when it gets sent to the gateway.
That's right.
And the gateway, the ASM gateway needs a self-signed cert to terminate. And maybe that didn't get pushed there, but we can check that actually.
Yeah.
Let's look at West. And we could do, where is it in ASM gateways? Okay, get. Yeah, that's it.
Oh, there's no cert. It's just a default cert.
Okay, so let's just hack this real quick. Project equals over spike. What else does it need? Cluster name. O2. Yeah.
O2. Yep.
And then generate this cert and apply it. Okay.
What do you? Oh,
I'm just deleting it once it's applied.
Gotcha.
Okay. No, we know it works there.
Check to make sure. Yeah.
Rika, and it's going to West.
There you go.
Damn. Okay. Sorry, y'all. This is why I put 2 hours on. I need to edit this down and fix that. That's good. So, okay. So what we've done then is we've rolled out an application to 2 clusters. And we've shown, the West goes to the West, East goes to the East. So it's using like least latency to get me to the right location.
We're using waves to control
deployment.
And
and I added a cluster. I mean, I could do this better, but I added a cluster just using a gcloud command, gave it the right label, and it basically baked itself into being ready to get traffic.
That's right.
So the next thing that I want to show off really is Argo rollouts. So let me get that rolling.
Pun intended.
Pun intended. So just like with Where Am I, we're gonna create the team scaffolding from the app template. We do that with the script, which is team app add. Done this a couple of times. What's going? Oh, ass.
Make sure, ASP. Make sure we the host name, gotta change it.
Yeah, good call. Why is it failing? App
Add. It's app. You put app. It's app add.
Right. Team. I told y'all.
Yeah.
Hold on. Ads today. Team app add. Here's the rollout. So I'm going to call it rollout demo. This is the image I'm going to pass in. It's the project I'm going to use. I'm going to put it in a different team. So it's going to generate a new folder. And then I'm going to change this to Argo Spike instead of MC demo. Okay. It's going to do its thing. And then I'm just going to quick follow behind that with the rollout. So let's get it rolled out. Team app rollout. Okay. We'll change it to purple, and I'll reset all this. Wave 1. Okay. I'm just getting all the branches set up so that we can do this. So now everything's hunky-dory. If we go back in here and I sort by teams, team 1, the rollout demo is getting pushed out. There is an error. Why is there an error? Oh, the path does not exist, but the path does exist. It's just going to take a second because I just pushed it up there. Teams, team 1 rollout. Let me just make sure. Argo, teams, team 1, rollout demo. Yeah. It'll catch. There it goes. Come on.
It's building out all the pieces.
Yeah, this is sort of the race condition that can occur when you're pointing at waves that don't yet exist.
Yeah.
Pointing at folders that don't yet exist in the wave. It takes a little time, but it will retry and catch itself. One way to make it happen faster is I can just delete the application, right? So if I delete this application, the application set's going to go out and create another one straight away. Okay. And this one's good. So I'm going to do that just to make this go a little bit quicker right now because we are coming up on time. Okay. Bam. This is degraded. It's rolling out. Spec strategy, virtual service, invalid. Oh, that's okay.
What did it say? What was not found?
It's looking for a virtual service that is being installed right now. So it's
yeah, gotcha.
So if I go into West Gateway, it's that 30-second poll. I need to get the Git webhook set up, and then the virtual service create.
Yeah.
Where's the other gateway? Nope, that one's already there.
That was synced already. Yeah.
Okay. So go back into team 1.
It almost happened so fast there.
Yeah. So now we're good. So this is running. It's running in both apps, and this is a really neat app that the folks at Argo maintain. Oh, here we go again. It might just be taking a second to get an endpoint registered. Rollout endpoints. Oh no, it's the wrong URL. That's good. That makes me feel better. It's Argo Spike. Here we go. Yeah. So this app is really neat. There's only one instance of this app running in 2 regions. I'm getting, because of my location, I'm getting sent to the East region. So this is the East region app, basically giving me a tile that represents the image that I've deployed to it. I've deployed the purple image, right? And I think what it does is it reads the virtual service and reflects what the virtual service gets adjusted to as the rollouts go out. But what you'll see is as I do a rollout, the tiles will change to the new image. And then I could do things like inject latency or errors to cause the rollout to fail. And you can watch the rollout fail back. Let's kick off the rollout. And then I'll show you what the rollout spec looks like, how I configured it, a couple other things, and we'll go from there. So we are going to change. What color do you want, Eddie?
Let's do my daughter's favorite color, which is yellow.
Oh, no, this is gonna be like LSU colors then. We're gonna start some wars. All right. So all I'm doing is updating the yellow image on this rollout, then pushing it to wave 1, right? So if we watch Argo, let's go to wave 1, which is the West Coast. We can wait for it or we can induce a sync. I'm going to just go ahead and, for time's sake, just push the issue a little bit. And what you're going to see happen is, see it rolls out another replication set.
Yep.
That pod's going to initialize. It's going to set up. It pauses, and then I have the virtual service in another spot. So we'll go over to West Gateways. And you can see that virtual service is set to 80/20.
Gotcha.
That's one thing actually too that when I create this application set, I have to ignore the whole route block of the virtual service because otherwise it'll just thrash.
Right.
I'll adjust it to 80/20 and then config sync Argo CD will sync it back to 100/0.
Right.
I can't watch that part in order for this to work. You can see the desired manifest is still 100/0.
Yeah.
But so it's gonna wait 4 minutes, run a check, and then move to the next step. So let's take a look at what the rollout looks like. Actually, I think I can probably just show you in here. So I'll go back into team 1. You can see it's paused. If we look at the rollout spec, it's easier to look at desired just because it's cleaner. Yeah. So what you'll notice is that it's a deployment spec. So the rollout spec replaces the deployment. So everything below the strategy is basically a deployment template.
Yeah.
Right. What changes is the strategy, and you could do blue, green, canary. I'm sure there's, I think, mirroring too. So when you fill out this strategy block, I chose canary. I had to create the canary regular. These are just regular Kubernetes services. And then I create the, actually later down here, I define the traffic routing is using Istio and call out the virtual service.
I love that. I love that about Istio rollouts, their integration with Istio, which is kind of cool.
Yeah. You could do it just with a gateway too.
Yeah.
But then all of your traffic has to go through the gateway when you're testing. So you won't get any of that east-west within the cluster failover checking. So it's only for apps that are exposed to the gateway if you want to use the gateway. And I see some customers doing some weird stuff then. They're like, oh, well, we'll just route all traffic between service A and service B through an ingress gateway. And you're like, no, for the love of God, don't do that. Why are you adding all that?
Latency doesn't matter. Sure, why not?
Yeah. All right, so the wait starts at 20. It pauses for 4 minutes, and then it checks this analysis template. And the analysis template, it's kind of cool.
So this is like kind of built-in testing, technically.
Yeah, exactly.
Built-in integration, end-to-end smoke test, whatever you want to call it. That's kind of cool because I can do like smoke test against the endpoint, right? And as like as an SRE, that's cool. I can say, oh, okay.
No, it's neat. So they have this cluster analysis template CRD. I'm using the Prometheus provider.
Sure.
And actually, one thing to call out here, excuse me, I don't have Prometheus running in this cluster at all.
That's right.
Envoy emits Prometheus metrics.
Right.
Okay. The Google Cloud monitoring agents and metricing agents scrape those metrics. They go in the Google Cloud monitoring backend storage system, right? And then we just added this. So you can either query over those with the traditional query language we have.
Yeah, Google.
Or you could use Prometheus.
Right, PromQL.
Okay.
Yeah.
And you also get a Prometheus endpoint.
That's right.
Oh, free. Like there's no
right.
charge for this. You get it when you pipe metrics in. And what I did was, one of the things I have deployed in here is just a Prometheus front end, right? So this is just the front end. There's no data. I created this front end, and you have to tell it which project to point to so it knows how to make the connection string. And I set up workload identity to give this container access to reading cloud monitoring metrics. But now I can have tools query against Prometheus locally in the cluster, and it's going to go out to this back end that we have in GCP, which is amazing. So
it's like all the greatness of having Prometheus local in each cluster for the data you need, but the data itself is now in limitless cloud.
Yeah.
It's awesome.
Good job on the metricing team and the Google managed Prometheus team to make this work. And I just love that we're not now. Billing does kick in if you start doing custom metrics and custom monitors, but there's no extra billing incurred for this. You know what I mean? Which I think is pretty amazing. So basically, I have a query that takes total requests that were returned 200 over total requests. So thus getting like a success rate.
Right. One of the golden metrics that SREs care about, right?
And if it's 95% or greater, it will move on to the next step. Yep. And that's all it's doing. But you can get really fancy with this stuff.
Tying back to, again, SRE and our DORA metrics and things like that. So like as you start building your dashboards for releases, this is huge, right? Like now I can start saying, I can automate some of the fact that my releases are passing based upon the SLOs that we've defined for our release schedule. So this is
and one of the steps. So this is my bad, and I don't have time to fix this. Maybe I do. So one of the things that I needed to do, and I have to add this to the build scripts, I actually have to give the Prometheus front end service account, Kubernetes service account, role-based access controls to read out of our metric store. And I didn't do that. So what you're seeing here is it's a failure, but it's a failure because client error 403. So it doesn't have permission to get the things that it needs.
Oh, so you have to give the KSA a GSA mapping back to. Yeah, gotcha.
Actually, I mean, let's see if I can do it. We got 8 minutes. Maybe I'll figure it out. So only reason why I'm actually trying to get this done now is because it's a pretty neat feature. So in Google Cloud, you no longer have to create the GSA binding for a lot of our services. You can just bind directly to a KSA because when you use ASM, you get a fleet identity and it uses the token from the Kubernetes service account to authenticate. And then takes that token, says, okay, you are who you say you are, and goes and gets an actual Google Cloud token based on the claims that you've assigned to that specific identity. It's pretty neat. I just need to remember what the command is in my history. You know what? I think I have it in the script right here. Because it's also one of the steps that I'm going to need to get the Connect gateway to work with Argo CD, because you have to give the Argo CD service accounts access to the other clusters.
The other clusters, right.
So I think that's in cluster add. Yeah. Cluster add. Let's see if we can get this to go. No, it's not there. If it's not in cluster add, then it's in fleet prep. So see this command right here. This is basically what I need to do, but I need to do it for, no, that's not it. This one.
No, this one. Yeah.
I'm going to search through my history. See if we get lucky.
You minimize your.
Oh yeah, Command J, folks. All right. That's not it. I'm going to show. I know it. Prod Tools default. There it is.
That's it. Yeah.
So this binding is getting applied directly to a service account, the default service account, which is a poor practice in the Prod Tools namespace.
Is that where that was installed?
Yeah.
Yeah. Right.
Yeah. And so now I'm going to cheat. I'm going to go into applications. Where can I see this? Where's Prod Tools? Prod Tools is in
MC, the central. Yeah.
Yep. I wonder if it'll just pick it up. It should just pick it up, but
We're gonna try. You gonna remove
yeah,
it?
I'm just gonna create some heck for a second. Somehow heck. So it's been in the South too long, y'all.
What?
My grandmother.
What the hell?
She laughs at me. So for the Twitter world out there, or whoever's watching this, I'm from New York City, and you do not know it anymore. So when I go home, I just get ridiculed.
Well, we're both from New York, and none of us have a New York accent.
Yeah,
so.
exactly.
You get rid of it. It goes away pretty quick. Except when I say sandwich.
Sandwich.
And mirror.
That's awesome. I'm just trying to think of what I can do to. There's a command that you could do to re-roll, but what I'm going to do is again cheat. So let's come back in here, projects. We'll go to team 1. You see it failed the analysis run. So if I
can you just delete the analysis run and see if it'll just because
not the analysis run, but if I delete the let me get this right. I think if I delete this, it should go. I just don't know if it's going to rerun the analysis. And what we could do just to, well, you're not going to be able to see the visual then. So let me see if
something just happened.
Yeah. It's rolling. It's rolling the other pod. I just don't know what. Let's see what. So it's purple.
Yeah.
So this is the one I need to delete. I think the whole thing needs to be rebooted.
Yeah, no, that's the one. That's the one because it got rid of the analysis at the same time.
Yep. So now it should just re-roll. Well, actually, it's just going to fail forward, I think. Yeah.
Mm-hmm.
So that's one way to fail it forward. Okay, so I want you to see this. Can you hang out for an extra couple minutes?
I'm good. Yeah.
Okay, so let's well, first of all, because I love your daughter.
Mm-hmm.
Oh, it's in West Coast, so you're not going to see it anyway. We can fail this forward, and we'll get we'll be able to see yellow, which is important.
Yeah.
So let me run that rollout and update the wave to 2. 1. It's going to go to 2. Now this should go off a little bit smoother than the last one. So that's west. Let's go to east. Let's just make it sync faster. I wonder if I need to see if there's a GitHub command to create a webhook. I'm sure there is using the GitHub CLI. Then I can just code it.
With the GitHub CLI? I don't use the GitHub CLI. Nothing wrong with it. I just never use it.
It's the only way I found to create a repo without just constructing like constructing okay. Come on, buddy. Now we have to wait the 4 minutes, but I think we should be able to see some yellow here. There you go.
It looks greenish on my side, but I'll believe you.
Does it?
Yeah, I don't know why. It's just the way the video is coming through. It looks green.
Yeah, okay.
That's okay.
Yeah. So right now, 20% of traffic is getting sent to yellow, and
right. Because that's the 80-20. That's this rollout right here.
It's going to take 4 minutes. And then at the end, I think I just need. We've been kind of all over the place. Just to recap, like the way this worked.
Yep.
If it worked right.
Yeah.
I have a change to my app. I push that change to wave 1. Wave 1 updates the image and causes a progressive rollout to all of the wave 1 clusters. In my case, it's just one.
And because we are tying into ASM, we also add a virtual service waiting to go 80-20 instead of 100% to the.
Well, yeah, it runs through the progression. It does 80-20, then it does 20-80. It runs analysis at each step of the way.
Right.
And then when it's finished, at that point, it's almost like a gate. Like you'd probably build some sort of notification system, right? So, okay, wave 1 is done. Make sure you're happy with everything. If you are, promote wave 1 to wave wave 1 branch to wave 2.
Yep.
And then you roll out to the rest of your apps. And this could be, you could have 5 waves, 5 branches. What do you think, actually, while we're waiting for this to roll out?
Yeah.
What do you think about, there's part of me that thinks that we should be doing, like I should create a like a SHA for the new image, a new branch based on that SHA, and then replace the application or tell the application to sync to the new SHA for a wave.
That's instead of branch, you're saying?
Yeah. Instead of long-lived branches.
Yeah.
I think that's the way to go. But then you have to write something that's going to update your application set. Yeah,
you have to create some, but that should be part of your CI anyway, right? Like as your application, you just have it because it's a single repo, right? But like you got to think about like as at the end of your CI is just your container image, but also anything else that you need to change configuration wise to update the stuff that's the configuration setting. So that would just be part of the end of your CI.
So wave 1, create, so you create a, not wave 1, sorry.
Yeah.
Yes. So you have application sets for each wave. They're all watching main in normal state. You have an image, a new image that gets pushed out. You add it to, you create a branch based on the SHA, some unique SHA or whatever.
Mm-hmm. Yep, the git rev. Yep.
And then you update the application set that wave 1's looking at to point to that.
Yep.
Everything's done. Everything's good. Then you do the same thing, and for application set 2, you point it to that same SHA. Everything's done. Everything's good. Right.
Yeah.
Then when all of your waves are done, you merge that back to main and point both waves to main.
That's right, because main should always be main should be representation of what's currently running in static state, right? In steady state.
I need to write that out just to have it down.
Yeah,
so you can see it stepped up to 80-20.
Yep.
It created an analysis run. So you get one of these for each step.
Each step, yeah.
Yeah, and you get results. My results were 1 because I didn't inject any errors. Right. If I injected errors, it'd be different. And it moved on. And in another couple more minutes, it'll finish. And that's kind of the end of the demo. So,
and we're fully on yellow on wave 1, and then we will say, okay, we're good. Nobody's complaining. East Coast customers are good. Let's go ahead and update the rest of the clusters.
Yeah, I don't know what this curl is going to return. I wonder if I could see the image name. No, that's the West Coast.
Yeah.
Yeah, it's JavaScript for sure.
Oh yeah,
I'm not gonna be able to see it. But yeah, West Coast is fully yellow right now. Yeah, so
that's cool.
Eddie, thank you so much, man. This has been.
Yeah,
I didn't think we'd use 2 hours, but due to my incredibly amazing coding skills,
Look, this is how it works. This is more fun because I like we love to break stuff to figure out why it's broken and fix it. So,
yeah. So,
and we didn't, and this proves like we didn't script any of this ahead of time. Like Nick did all the work. He just asked me to come on and say pithy things, which I probably failed at doing pithy things as well. But yeah, I mean, it's like this is kind of like this is how Nick and I have worked for the last 8 years that we've been working together. So
yeah. So maybe we'll do some more of these things. I plan on doing something similar with Flux. I'll even do one with config sync, which is our tool. It'll make all of my overlords happy. And I've got some other things lined up with Pixie and some other stuff. So, dude, I really appreciate your time.
Yeah, brother. Always, you know that.
It is a Friday, so I hope everyone has some good plans. My kids are gonna take over my life in about 2 more hours. So happy Friday!
We're at 105-degree Austin weather, so we're gonna hit the pool as soon as we possibly can. So
you hit that pool. And
you take care, guys. Say hi to the girls for me.
Ciao.
Ciao.